Welcome to myprojectbazaar.com. Project title: An optimal scheduling algorithm for maximizing throughput in WiMAX mesh networks. Let's see the abstract of our project. First, WiMAX mesh network is a promising technology for broadband wireless networks. In this project, we have done the enhancement work of the paper. So, in order to achieve the fast, cost-effective network deployment, and handling of mesh subscriber stations is required to prevent from failure. The node failure is overcome by a new technique called multi-sponsor mechanism, which is proposed in our process. This will enhance the reliability of multi-hop communication path in the network. Let's see the flow of our process. First, the network is formed. It is done by the number of mesh nodes and the base station. After that, a source node generates data, that is, a source forward the route request in the network. For that, the route have to find. So, in that, the multi-sponsor technique is implemented in this. It is done for the routing path is find without the error. Hence, if any fault is occurred or not is checked in the route. If the fault is occurred, then it is recovered by using the threshold value. If does not have any fault, the route is established and then the packet is communicated. Finally, the performance is analyzed. Now, see the running procedure of our process. To run the code, open the terminal window. In that, first go to the directory where we have the file. Then ns space filename.tcl is given to run the code. Here 40 nodes is created in the network and the routing path, that is the route is established in the running time. This is the animator window. Here only we can see the output. So this is the play button. To run the simulation, click the play button. This is speed of the simulator. So here the network is formed with a number of mesh nodes and here is the base station. Now the node 21 enters for the communication. Here the source node generates data and forwards it to the base station. This process is done at the various simulation time and also the neighbor nodes are updated in the route which was displayed in the terminal window. Here we see, so at the simulation time, which node transmit in which route is get updated with its sequence numbers. So it is feasible to find the fault node that occur in the routing path. In this routing, if any fault occurs in the route, then it have to be retrieved in the path. You can say that in this way, first this route is not feasible. That is, it does not send packet to the base station. So only the source node send packets in the another routing path. So here the node 27 transmits to 13 and then 2. So here a fault is occurred in the route. So with the acknowledgement and the threshold value that does not return to the source node, it transfers in the another routing path just like 27, 13, 1, 11 and 0. So like this it forwards data to the base station. Here in another side there is no fault occur in the root, so it transmits data efficiently. The result of this communication is analyzed through the performance, which can be viewed through the graph results. So, to see the graph, type new plot graph name.plot. So here the number of centers is compared with the delay. In x-axis the number of centers is varied, and in y-axis average delay is represented. So if the number of centers is increased, how we can calculate the delay of the packets that reach from source to the base station. The existing system have a much higher delay, but our proposed system, that is the multi-sponsor technique, have less delay. Now see the another graph. So here the routing overhead is compared with the number of centers. So by varying the number of centers, the overhead is high in the existing system, which is much reduced in the proposed system.